Hello everyone, this is the first lesson recording for IM1 September 4th. You should have your notebook ready and you are going to be talking to either your teddy bear, your pet fish, or little brother, so have that ready later on. Okay, so what we started off with was doing some warm-up on the Desmos activities. So what you need to do if you're watching this and you did not get to it because you were absent, you're going to go to studentdesmos.com. and then you're going to type in the class code depending on what period you were. So you are going to be working on those 16 sheets of Desmos. They're not 16 problems. Some of them are just explanations of things, so it should not take you too long. So please pause the video and do those first, and then we will go on with the rest of the lesson. So after the warm-ups, we are going through the functions, new notation. The warm-up should give you immediate feedback as to whether you're solving those problems correctly or not. We are doing that right now because we were going to have the absolute value evaluating expression quiz today. I am actually postponing it to next class, and that means next Wednesday when you come back after the long weekend, we're going to do the quiz. And hopefully by doing the warm-up, you should have a quick reflection. You should have an accurate idea as to how well you know the material. Okay, are you getting those problems correct? Are you comfortable? Do you feel confident in those? So to prepare for it, you certainly should review the homework number 4 that was on day 4, as well as last homework, as well as class notes from 8:25, and then warm up from today, obviously. So there is going to be a quiz retake today. Today is 9/4 September at 2:10 during my study hall. So if you have prepared for it and you think you can do better, please turn up and you can do the retake for the quiz and raise your grade. Option for getting help. If you're having problems, come to study hall, or you can get peer tutoring from MESA on Tuesdays after school. The homework center is not up and running yet, but as soon as it is running, I'll let you know. Let's quickly review what we did last time. Okay, so we started talking about function machine, and we started talking about what is input. Input is the number or something that is going into the machine, and the output is what comes out of it. We started talking about the function having a role, or it has a function. It has something that it is doing. It could be in algebraic expression, or it could be in words. So in this case, it's multiply by 5 and add 10. So we can represent the result in this input output table. Say for example, if we inputted number 2, and then the machine, what does the machine do? It multiplies by 5 and add 10 to it. So multiply 5 by 2 is 2 times 5 is 10, plus 10 is going to give me the output of 20, and I can put it in the table like so. Okay, input was 2, output was 20, and we're going to start to use the terminology X here. X to represent input and Y to represent output, and depending on what values that we inputted, and then we got different output and so on. Okay, now we can represent this machine, what this machine does, in this simple equation. Y is equal to 5x plus 10, where x represents the input, y represents the output. So y, the output, is going to be really multiplying the input by 5 and then adding 10 to it. That's exactly what we've been talking about. Now we're just representing it as an equation. We can do the same thing with when the rule is in written form, in expression, and we can come up with different inputs and outputs, and the rule was multiply by 2, subtract 4. Okay, so that's what this one did, and we can again represent this as the x being the input. Now input is x and the output is going to be represented as y, and we can simply use y, the output is 2 times x, 2 times the input, subtract 4. So we can start using this to represent this what this function machine does. Okay, then let's start by doing some card sort. So I have these 2 different description, and I want you to come up with algebraic expression that represents each one of them. They look very, very similar. It's just slightly different. This one says take 6 from n, then divide by 2. This one says take n from 6, then divide by 2. That's a typo here. There should not be 2 divide here. Alright, so you should pause the video and see if you can translate this into algebraic expression. I am going to show you the answers right now. Okay, so take 6 from n. That means you are taking away 6 from n. So it should look like n minus 6. And then whatever the result was, you're going to divide by 2. What about this? This one says take n from 6. How is that different? The difference is you're taking n from 6 and then divide by 2. So they look very similar, but there are two different expressions. Why is that so? Because with subtraction and division, the order matters. If I just swap those two numbers, it's going to come up with a different answer. Just like 5 minus 3 is going to be different from 3 minus 5. So you need to be really clear on that. Let's do another one. This time it's in algebraic expression. Can you come up with word description of what they do? They are very similar but slightly different. Please pause the video because I'm going to show you the answers right now. Okay, so this one, remember the order of operation. You need to apply the exponents first before the multiplication because exponents is higher in the order of operation. That means n is being squared. So square the n, and then to that result, you're going to multiply by 3. What about this one? We have parentheses. Remember, parentheses is a grouping symbol that is higher than exponents, that's higher than multiplication. That means we need to do the parentheses first. So we are going to multiply n by 3. 3n means you're multiplying, and that result is being squared, the answer. Okay? So that's the difference. So make sure you're clear on that. Next exercise we went through is what is the function? We are given this input and output table that is partially filled. Okay? And we're going to try to guess what the row is and then figure out what are the missing numbers and fill that in. So for the box with, so look at what information we are given. We are given 1, 1, 7, 49, 5, 25. That means that when input was 1, the output was 1. Is it just the same number? Well, if that was just the same number, then this should be 7 as well. When input was 7, this should be 7 too, but it's not. So just putting the same number as the input is not going to be the rule. Okay? But 5, when I put 5 in it, it came 25. So you need to start thinking about how could the input and output be related? Okay? Or so you can pause the video and think about what the rule might be, and think about what the empty spaces, the answers to it. Okay? All right. So I'm going to assume you had a thought, and I'm going to give you a clue. Okay? So if I see that 1 times 1 is 1. Okay? Or it could be 1 plus 0. But that rule does not work here, right? 5 times 1 is 5, not 25. 5 times what is 25? 5 times 5 is 25. Okay? Alright, then can I apply that rule to here? Is 7 times 5 49? No, 7 times 5 is 35. So that's not true. But 7 times what is 49? 7 times 7 is 49. So does that give you a clue to what the rule might be? 1 times 1 is 1. 7 times 7 is 49. 5 times 5 is 25. That's right. The rule is that you are squaring. You are squaring the input number. So if that is the case, what do you think is the input here? What do you think is the input there? Or what do you think is the output when the input was 4? And so on. So please stop the video and fill in the rest of the table if you have not done so already, and I'm going to show you the answer. Okay, here we go. The missing number was 3 because 3 squared is 9, and 10 squared is 100, and 2 squared is 4. And if the input was 4, what is the output? It's going to be 16, and so on. Okay, so again, the input, we're going to start to think about it as x, and the output is the y. And we have the representation of y is equal to x squared. Okay, now we're going to introduce yet another notation, f of x. F of x is going to be exactly the same thing as y. It's just the same thing, so we're just going to replace it. And so that means what used to be y is x squared, we can replace this as f of x. This is the function notation. This is what we call function notation. And I am going to show you a quick video. Okay, all right, so I am going to reiterate what we talked about in the video. So function notation is used to represent relations that are function. So the old way was we used to represent it as y is equal to 3x plus 5, but now we're going to represent it as f of x is equal to 3x plus 5. Notice that the x and x here, they match up. Okay, so what do these different parts mean? This 3x plus 5. 3x plus 5 was just the rule of the function, just like it was before. And f of x is the output of the function. And we read this as f of x. And this is not the same as f multiplied by variable x. This is a different notation. F represents the name of the function. And this can be many different letters, but most commonly we use f. And then finally the x is the variable representing the input. So you should pause the video and take notes right now. And I'm running out of time, so then we quickly went on to doing some teddy bear math time, where we are saying out loud what different parts meant. Okay, so you should be verbalizing this right now. verbalizing this right now. You can pause the video, and I'm going to continue in the next video, please.